Certainly, if you went back over my notes, I put a lot of recipes down, but for the most part, recipes are, they're hard to recall all the recipes I've given you, and I just simply say, you try something. And so I see as a cube there, I'm gonna borrow a tangent from it. And so what I mean by a tangent, if I borrow a tangent, I'll have a tangent squared. Right, and I want to point out that 1 plus the tangent squared x is equal to the secant squared x. And we've been using that for some time now. So the tangent squared is going to be equal to, secant squared x minus 1. And that would be a dx over there. All right? Now, of course, looking at it, I think what I could do is, maybe multiply through with it. And again, it could be a dead end. There's always a problem with dead ends. You don't know where to go with that. Let me write this as tan x times secant squared. And secant squared, I'm going to write it as secant times secant. And then I'd have minus the tangent of x. And that would be dx. I'm going to split into two integrals because I think I'm seeing something. And I'm seeing the first integration, tan x secant x times the secant x dx. The second integration, I'm going to write it as sine of x over the cosine of x dx. Over here, I kind of recognize something immediately in the first integration. And what do I recommend? Not recommend, but looking at this thing over here, I'm gonna say this is the u, and then this would be the du in the problem. So you get u squared over 2, so you get secant squared x over 2. Again, so as I said, this is my u. The derivative of u is this. So I would have the integration of u. So it's u squared over 2. But again, u is secant, so I get this over here. Not so bad. The other one I'm going to do is recommend this over here is kind of looking at it. And, I'm going to recommend that this would be the u. Right? And then the du there would be, the minus sine dx. So I'm seeing it is actually plus, the antiderivative of 1 over u. So it's going to be plus the natural log of the cosine, the absolute value of cosine, plus c. All right, put a little box in this. And I'm going to commit to that answer. Well, certainly committing to an answer doesn't mean it's right. Just means that I can't see much else to do with that. But let's see what we got over here. And I'm thinking I might have made a mistake somewhere. And where's my mistake? Let me take a look. I don't think there's a mistake. I want to point out, I did something different, didn't I? And that kid, I want to look at it. I mean, it's always problematic when you're looking at keys and you're wondering, did I get the same answer? Well, what I want to point out is what I did up here. I'm going to be careful about it. I did something different. There's no doubt about it. And let me see if I'm really a lot different. I don't think so. It's a lot different. But let's see, secant. And yeah, I got that. And I got this over here. My answers are different, though, aren't they? So someone says, I wonder how that could be. The answer looks so remarkably different. I mean, these look the same. Oops, sorry about that. I got this looking the same. I did it again, didn't I? Not very good with aiming the stylus here. So this is the same. And I'm really kind of looking at this and saying, what went wrong there? Now, certainly, you certainly would experience, I know that they're the same answer. But, and the reason for that is the tangent squared and the secant squared, they only differ by a constant. So my antiderivative only differs by a constant, by the way. It's not the same C in each problem, by the way. But over here, I'm convinced that I'm good here, and I'm convinced it's really an equivalent answer. But I want to see what they did over here. And it looks like what they did over here, and I got to look at it. And let me see, looking at that, what they did to get that. And let me see, you got tan x. Yeah, look what they did. They said u. I'll write this down for you. By the way, I'm the one who did the k. I just can't remember doing it. That's when I worked the problem. I got a different, well, it looks like a different answer. It's not really a different answer. Secant squared x dx. All right. Will you get what they said? You sure will. You're getting u dx, which would integrate to u squared over 2, which is tangent squared. So this is also a good answer. And again, I want to convince you that these two answers here only differ by a constant. And what's the constant they differ by? Well, if you looked at it, 1 plus the tangent squared of x is identical to secant squared. So what I do is you take the constant, you just integrate the number into that, and that's fine because we have a constant over here each time. We can integrate the 1 into that. So this is a good example that you might get confused on exams, especially if it's a multiple choice exam. If you're looking at this answer, you'd have to have some idea that this would be an equivalent answer over here, and that's a good point. Thank you.